three spheres ABC as shown in figure are 100 Newton, 160 and 80. 100, 160 and 80. Identify the contact. Is it contact 1? So make it point number 1 and show N1. N1 is normal reaction. Then this one is contact 2. Make this reaction equals to N2. Then this one is contact 3. Make this reaction equal to N3. This one is contact 4. So make this reaction equals to N4. Then this one is contact between the two rulers. So this one is point 5. This one is the contact between two rulers. So this one is point number 6. So we have 4 normal and 2 contact reaction. Now the contact reaction between A and B will act along this line, and the contact reaction between B and C will act along this line. Now to find out the angle between this line, what we do is that we'll drop a perpendicular from this and we'll draw horizontal from this. This is the extension on this line. And we call this angle equals to theta. Now, what is the radius of cylinder C? 100. So is this distance is 100. Now from this, if you draw the extension, then what is the radius of cylinder B? 200. So can we calculate the distance between these 2 points? Is it 450 minus 100 minus 200 equals to 150. 150 is correct. Okay, take out this cylinder outside. Let's call this point equals to D point. And take out this cylinder, and this angle equals to theta. If the distance CD is same as 150, so this one equals to 150. And if the distance between B and C is the radius of cylinder C, that is 100, plus the radius of cylinder B, that equal to what? 200. So can we cos theta will work. So cos theta equals to adjacent is 150 and hypotenuse is 300. So is the angle theta equal to 60. This total distance of the channel is 450. Now project perpendicular from this point A. Confirm this distance is equals to the radius of cylinder A, that equals to what? 140. Now similarly draw one more perpendicular from point B. Confirm this distance equals to the radius of cylinder B, that is equals to 200. 200 plus 140 is equal to 340. So is this distance is 110. 110. So I can continue with my triangle and I will call this point equals to E point, and I will take out this triangle outside again. A to E is equal to 110 and A to B is the radius of cylinder A, which is equals to 140. The radius of cylinder B, that is 200, equal to 340. This angle I will call as beta, and therefore cos beta will be adjacent is 110 upon hypotenuse is 340. So we can very well work out angle beta is 71.12. Very first thing, you have to transfer weight 100 Newton. Show 100 Newton arrow inside the cylinder. Show 160 inside the cylinder, and show this 80 Newton inside the cylinder. After this, transfer your normal reaction. N1 is acting at point, N1 is passing through A. So show N1 is passing through A. N2 is passing through C. So N2 is passing through C. N3 is vertical through C. So N3 is vertical passing through C. And N4 is horizontal passing through B. So N4 is horizontal passing through B. And finally, we have to show the contact reaction. Is this cylinder A will push cylinder B in a downward direction? So show the push. So this one is action. So this one is reaction. And this point we have shown as 5. So label this one is N5. When you observe the cylinder B and C, will the cylinder B will push cylinder C in this direction? B will push cylinder C in this direction. So it will push this way. So this one is action and this one is reaction. And this one is N6. The angle made by N6 with horizontal. So that angle equals to what? Theta. And how much is theta? Is 60. And what is the angle made by N5? That is this point. Is this angle is same as beta? Beta. And this angle is 71.12. That complete the FBD. Okay, consider FBD at A. So for FBD at A, this one is your axis system. Draw a separate figure at this point. So you can show this point equals to A. The weight is 100 Newton is acting always vertically downward. Your N1 is entering, so we'll transfer it on the same line so that it will become outward force N1. Your N5 is in the fourth quadrant, so we'll shift it in the second quadrant. Is 71.12. Now we have three forces and the body in equilibrium, so we can very well apply Lamy to find out the angle between the forces. What is the angle between the value of N5 and 100? Is 90 plus 71 is 161.72. The standard angle between 100 and N1 is 90. Remaining angle you can find out by subtracting remaining two angle from 360 is 108.88. This theorem. We'll start with 100. 100 divided by. If you want to write down 100, then you write the angle between N1 and N5. And that angle is 108.88. For to write N1, you write the angle between other two forces, that is 100 and N5. So this one is sine of 161.72. You write the angle between other two forces, that is N1 and 100. N1 is 33.14. And what is the N2? Is 105.68. Now consider FBD at point B. Show this point is B. Copy down all forces. This one is 160. Now this N4, this N4 will shift to the left hand side. N4 is inward, so it will transfer to the same line. Idea is that all forces must be outward. Next is N6. N6 is acting in the third quadrant. Third quadrant will come in the first quadrant. So N6 is 60 degree. From this side, N5. Now this N5 is in which quadrant? Is second quadrant. Now we'll shift into the fourth quadrant. 5.68. Angle made by this force is at 71.12. Now this time we have four forces, so we have to apply sigma fx and sigma fy. But before this, you have to resolve the forces. I told you, you divide your page into two parts and solve this figure. So just make two parts, write down one sigma fx and other side write down sigma fy. In this case, sigma fx, the value of n6 cos 60 is positive. This value is positive. Then n4 is negative value. N4 is negative value. N4 is negative value and 105 is positive value. Shift to Fy. In Fy, N6 sin 60 is positive value and 160 is acting downward is negative value. And this 105.68 is also negative value. N6 is it 300.25. And put this value back at this point of N6 and solve this value for N4 now. Of N4 is 183.27. Answers are in Newton. Okay, consider FBD at C and let temporarily show this our coordinate axis system. This 80 Newton is acting vertically downward. So this 80 Newton is acting vertically downward. This N3 will act vertically upward. This N2 will shift to the right. N2 will shift to the right. And we have N6 present here in the first quadrant. that will going to shift in the third quadrant. Value of N6 is this 300.25, and we'll put this value equal to 300.25 made by N6 is 60. This time again we have four forces. So what we do, we'll resolve the system like this. Divide your page into two parts. One is sigma fx0 and one is sigma fy0. Make entry along x-axis. So N2 is positive force, 300.25 is negative force. So this value is around 150. 150.125, that's correct. And what about sigma fy? So N3 is positive, T is negative, and 300.25 sine 60. Whatever the answer come, I know the answer is 340, so I will just write, otherwise you write this, whatever the answer comes. That is your choice. Okay, we have given one circular roller. This one is circular roller. What is the weight of this one? The weight of this one is 100 Newton. Radius is 10 cm. This one is rod. And what is the length of AB? 20 centimeters. The first thing you tell me, because of this self weight, is the length of AB will increase or will decrease? Increase. If the member length will increase, is this member length is in tension? So you have to show tension. Do you have contact here? So we have one contact reaction and this angle. Can we write down this angle equal to theta? For this right angle triangle, for this, that is cos theta. That is 10 divided by 20. Theta equals to 60. Is this fine? Now in mechanics we have full freedom to cut internal forces. So we'll cut here. So if you cut this and you separate this body, then your body will look like this. And in that case, weight will act downward. This force is inward, so it will act like this. This one is tension. The tension is like this. So this one is tension. This one is NC. This weight is equals to 100. Angle made by tension is theta. And what is the value of theta? What is the value of theta? Theta equal to 60. Is it correct, everybody? Now the same ABD I will use for Lami's because I have three forces only. Now tell me what is this angle? 150. This angle, is it 120? Equal to what? 180. And what is the angle between these two forces? Is it 90? We can very well apply Lamy. So by Lamy's theorem, 100 Newton force is proportional to sine of the angle between other two forces, that is NC and T, equal to what? 120. Then the force T is proportional to sine of the angle between other two forces NC and 100, that equal to 90. Finally, NC is proportional to sine of 150. You can find out T and you can find out NC. Now just imagine that we have two cylinders on one horizontal plane. Imagine that if you want to keep another cylinder and heavier cylinder over this heavier cylinder, this cylinder will try to move on this side and this cylinder will try to move this side. So what we want is that we want to make this stack. We want this assembly. So shall we have one arrangement is that from this center to this center, if I connect a thread, then is this arrangement is possible. And therefore every time this cylinder will try to go this side and this cylinder will try to go this side. So is the length of this member always increases. If the length of member will try to increase, then is the hair gap is produced here. Small hair gap will produce. Therefore, are these two cylinder will lose the contact. But is this cylinder and this cylinder will be in contact, and this cylinder and this cylinder will be in contact. So the contact between these two cylinders is always there. But because of this cylinder, they will lose the contact. So it will go slightly rightward. At a contact point, do you have one normal reaction here? We have one normal reaction here. We have one normal reaction here. Let's call this normal reaction equals to, and this normal reaction equals to what? And this cylinder and this cylinder, they are in contact. If you join them with this line, then do you have one additional contact reaction here? So let's say that equals to point number 3. And do you have one more contact at this point? That is contact between the two cylinders. So this equals 4. So how many unknown we have? N1, N2, N3 and 4. 4 unknown. Now are we able to find out this angle theta? To find out this angle theta, what we do is that we'll draw this line vertical. Now is this distance here is same as 100? Is this total distance from here to here is 200 plus 100 equal to what? 300. If you want to say this angle is theta, and if you take out this triangle like this dimension is 300. What is this dimension is 100. So can we find out this angle theta? Cos theta is 1 by 3. That is 100 divided by 300. So what is the value of theta? 70.52. As the cylinder C is kept on A and B, the two bottom cylinder will try there is no contact A and B. Okay. If we draw the vertical line from C, this one line, that is this part is the mirror image of this part. Exact mirror image. And even the load on this side, is it same as the load on this side? In mechanics, this type of loading is called as symmetrical loading. You don't have to solve everything. If you solve this side, automatically the same answer will repeat on this side. That is the advantage of symmetrical loading. So you also draw one line and write it symmetrical. There must be symmetry of geometry as well as forces. Then only it is called as symmetrical loading. For example, this is 50 Newton and this one is 60 Newton. Then you can't say this is symmetrical. Because geometry is satisfied, but the forces is not satisfied. So this force is 50 and suppose this force is 60, then we can't say it is symmetrical loading. We have to calculate all. But if it is both 50, then we can very well use the concept of symmetrical loading. So only half part is solved. Only half part. How many contact points we have? We have one contact here, that is 1. We have one contact here, that is 2. We have one contact here equal to what? 3. And we have one contact equal to 4. We don't have a contact between A and B. So separate this figure and draw the. Okay, we have separated 3 cylinder. This one is center A. This angle theta we have just find out is 70.52. So this angle is 70.52. This is also equal to 70.52. We have two reactions, one at point 1. So this one is N1 reaction and this one is N2 reaction. And in between the two ropes we have a thread and the distance between this is increased. So is the thread in tension? Thread in tension. Thread always in tension. Then this upper cylinder will push the A and B in the downward direction. So this one is the action by C. This is the action by C on B, and therefore they give equal and opposite reaction based on Newton's third law. We will call this point equals to N3 and we will call this point equals to N4. And finally we have a weight. Weight of this cylinder is 75 Newton. Weight of this cylinder is 50 Newton and weight of this cylinder is 50 Newton. So we will solve this half or we can solve this half, either of this. Because we have a symmetrical loading, so we will solve for C first, then A, or we'll solve for C first and then for B. Okay, consider FBD at point C. So this is the point C. The weight 75 will act downward. So we'll shift quadrant. So we'll shift it in the second quadrant. And this 4 is in the third quadrant. So we'll shift it in the first quadrant. This value is N4. This angle is 70.52. This angle is also 70.52. We have 3 forces. So we can apply Lamy and we can find out angle between the forces. So what is the angle between N4 and 75 Newton? Is it 160.52? The angle between 75 and N3 is 90 plus 70.52 is 160.52. We can find out this angle using 360 relation. 360 minus this is 52. We can apply Lamy. For applying Lamy, we have 75 divided by angle between other two forces is sine 39. Then we have N3. For N3, you have to write down angle between N4 and 75. That is 160.52. We have N4. For N4, we have same angle is 160. N3 is same as N4. Are same because our figure is symmetrical loading. Okay, consider FBD at A. So let's construct here the first reference lines. Axis at this point. We have a coordinate axis. Transfer 1 by 1 forces. 50 is downward. N1 will shift upward. This tension is rightward. Force is rightward. And N3, which is 39.7, will be shifted from first quadrant to third quadrant. The value of force is 39. So this one is 39.7 cos. Okay, our procedure is divide the page into two parts. One is sigma fx0 and one is sigma fy0. And solve the equations. In fx we have t minus 39.7 into sine of 70.5. We can very well find out t 13.23. And one force we can apply along y, that is N1 minus 50. N1 minus 50 minus 39.7. Correct answer is 87.5.